Hello guys, welcome to Digitronix Nepal ninth tutorial session. Actually, this is our ninth tutorial session on ZedBoard FPGA. So in this session, we are going to have a session on creating custom IP, intellectual property, like a design on VHDL. Previously, we already have a tutorial on creating custom IP on Verilog. In this tutorial, we are going to do on VHDL in VIVADO Design Suite for ZedBoard FPGA. So we can see here ZedBoard. So we will have a design which can be used for implementing on ZedBoard. So let's proceed on today's design. So so we have here instruction. So this is our ninth tutorial session, and we are going to create a new AXI4 slave IP, and we are going to do some customization on sources like AXI4 IP generation sources, which was generated by VIVADO IP, and we will customize and we will package it for creating a custom IP. Then after we will import that package IP in our VIVADO repository, which will be shown in IP catalog, and then we can interface that layered controller IP. Actually, we are going to make a layered controller IP, means that IP which have 8-bit of layers and which can be instruct or program through AXI bus. Means Zynq PS can instruct our IP layered controller IP through AXI bus, so it can be controlled via AXI bus. So our 8-bit layered will control by layered controller IP. So we can do some interfacing on layered controller IP with Zynq PS in our VIVADO IP design. So you can see lots of information about FPGA tutorials and FPGA research and development, FPGA design and verification at our website, and you can also visit our YouTube channel and you can subscribe it. You will get lots of references right there. So I will start actually VIVADO. I haven't started yet, so let's start VIVADO. And in this tutorial session, we are going to have a custom IP, so we can trigger or control our 8-bit layers. And previously we already have different type of IPs, IP like IP design session, and we already make different type of IPs also. We have different image processing IP, some control like automation IPs, and some video processing IPs, and you can get IPs in our website too. So let's wait some time for VIVADO. It is still opening. Okay, our VIVADO has opened. So let's start from okay, create new project. It will be more easy to create IP from create new project. However, we can also do from manage IP section, and let's reallocate this location to ZedBoard, and I have one session 2.2 for IP. So this will be layer controller, and I'll do next. And I have to change my source setting, because if I skip the source setting, then it will generate Verilog IP. So I need to have VHDL. So let's select VHDL, and other are as usual. So let's do next. And in board setting, we have to select our ZedBoard. So there may have some different boards, like I have also worked at Kintex Ultra Scale, KC105, Kintex 7 series, KC705, Cortex 7, and Cortex Ultra Scale too. But I haven't worked at like Ultra Scale Plus series of boards from Xilinx. So let's wait some time for working on that. So let's finish it. It will create just a project setting. Actually, we doesn't need the project. We are going to make a IP. Then after we will call that IP in our project, layer controller project. So let's Let's wait some time for initializing this project. So for IP creation and packaging, we need to go to tools, and we can go to create a package. You can do next. You can create a new AXI4 peripheral. So our IP will be layer controller, and we don't need to have set of version, but you can set to okay, let's do next. Actually we need slave port, we don't need to even change here. So slave light AXI 32.4. Let's do next. So actually only one single registers can also sufficient for us for addressing our 8-bit port, but we can select 4 memory sorry registers. So let's do next. Let's edit IP, select edit IP, and let's finish it, which will give us edit panel. Okay, we have another menu too, because this is our main project, and this will be our custom IP. So actually in this menu you can see this is the IP setting menu. We can change some setting too. So this identification doesn't signify any meaning. So let's go to this menu. So we can double click on this setting, sorry, these sources. Actually these are the sources. This is the main source for AXI interface. This source include slave mode of AXI bus protocol in our IP. So if we double click on it, it will give us these sources. So we will also need the sources too. Let's customize some parameters. Actually we need to add 2 things. We need to add one ports. Actually we need to add a ports, and we need to add a we need to add ports, and we need to add some logic, user logic at here, which we have identified and placed at here. We can see here. So we need to have these ports, our custom port leads out ports in port initialization section. So we can add out port here, and we can save it. And even we also need another user logic. Actually this is our user logic. So we are editing the slave AXI source. Actually another is top source. So this is our slave AXI source. So where we need to place is there must have some identification like insert user logic here. So we are going to add there. So it might be at last. Okay, at the last. So let's paste it here. Slave R is 0, 7 down to 0. What actually did it here is the value of slave R is 0 will be given to layers out. Actually layers out is 8-bit, and slave R is 0 is also 8-bit. So layers out will get input from their source. So let's again customize these sources to top sources. This is top sources. So we also need in this source we only need two things, two main customization, like port addition. We have add port, and we have add user logic. However, this is the top source, so we where we need like one ports, and another will be component declaration. We should add something at here, and another will be a port mapping. So in VHDL 3 things we need to customize it. So let's add similar name of ports. we can have different ports too, but we are going to paste this script we already have prepared for making very short time of video, because our video are becoming lengthy and lengthy, so we are making it very short and informative. So let's add ports 8 here, so we can paste here and we can save it, and we are going to need to insert these layers out after port of component section. Actually component is this component calls the previous source, these sources, which is layer controller S00AXI. This source or this program has been initialized or called, actually we can say called function, like it's function calling in C programming. So it has been called it here, which is layer controller B10 S00AXI. So let's paste it here. So our component is also ready. So we also need a port mapping, because this only initialize the sources into section, so we need to have some port mapping. So we need to identify the port map section. Actually here is port map. Actually port map did the interface between two IP sources. This is the first this is the main logical IP, and this is top module, so it will component in port mapping will interface the main module and sub module ports each other, so it can be connected. So this logic can also be seen at like open elaborated design. If we did this, it will give us a schematic. We can see schematic at there also, so let's do it. Create a schematic of our top module. Actually top module includes the base module. So this is our tutorial session, creating custom IP and VHDL, which is layered controller IP. We are going to design it in VIVADO Design Suit. You can use different design tools like Coratus or IAC, and targeting ZedBoard from Xilinx. Okay, we can see it here. Yes, actually this is the top module, and it includes, sorry, okay, we can see schematic at here. We are just going to point this. Okay, let's follow the other steps, like we have steps of edit IP, actually we need to okay, I think we get it here. We have just messed up. So let's go forward at this menu. So we are not going to change compatibility, but we can add some ports like RTX, which is similar, and we already have Zynq, so let's add RTX. We don't need to add some file groups. We are going to merge the parameters, and we are going to see the port setting. Actually our layers out is 8-bit 8-bit wide, and it has been activated on direction of out. So even we can see GUI of it. So let's see GUI. So here is our GUI. So we can see let's out and other AXI communication buses which are not necessary for us currently. So let's package it. Okay, let's have some setup at this create archive IP and create IP packager window also. Actually, what we have did here we have tick on activate create archive of IP, which will create archive in IP repository and add to VIVADO, and it will add to current project, add our IP to current project, and in the third session it will close the IP packager window, so our main window will be closed, and delete project after packaging. It will also delete the edit layer controller IP project, so we will just only get the package IP, which we can call it our repository manager automatically. We don't need to have some manual, so let's do it. Sorry. So let's package it. So after packaging, do you want to close the project? Yes, close it. So we will go to main window. So in this window we are going to insert our recently design IP. So let's create a new block design, and we can see here so we are going to create a custom IP of layer controller in VHDL, which is we are going to do we are creating it on VIVADO IP integrator. So let's create layer controller. This is our IP, isn't it? Layer controller B10. Let's insert it. So this is our IP. We even can insert actually the Zynq PS, and we can interface our IP with Zynq PS. So let's insert Zynq PS at our project. Okay, let's insert Zynq PS. Previously, let's make this port external, because we are going to do some give a output to our LEDs. So let's make external. It will automatically we need to update our constraint too. So let's we can make it external by this make external command, or we can also use Control T. So I'm going to use command shortcut keys Control T. So it must have, actually my command is not working. I don't know why. Okay, let's add Zynq PS to Zynq PS, and we will do some automation. It will automatically add the Zynq PS with our layer controller, which is actually a VHDL based IP. So let's run clock automation. Let's click OK, and let's do run connection automation. It will call some processor system interconnect for giving peripheral reset signal to our layer controller IP, and it will also insert AXI interconnect, which will give the interface between AXI4 slave and AXI3 master. So let's do run collection automation. It will add two major sections: processor system reset and AXI interconnect. After that, we are going to do validate design, and we will create a HDL wrapper, and we will synthesize it. This is the major process. So it's I told there are two sections. One is process system reset. Actually, this gives the reset signal to peripheral reset signals to our this slave device and AXI interconnect, and it takes the reset in from master. This is our master actually, and this AXI interconnect is here because of we need to have conversion between AXI3 master and AXI4 slave. So it will give some interfaces between xi3 and xi4. Master and slave, we can see just master and slave. So let's validate design. We going to need a constant of laid out, so we will place a constant and later. So let's create a SGL wrapper. Let me back to it. After that, we are going to do synthesis, which might take some minutes. I think it might take 10 to 15 minutes for synthesizing, and we will add constraint. I will show you. So let's do run synthesis. Actually, we should have inserted constant previously, and we should synthesize it. That would be better. But let's do synthesis, and after we'll add constant. Okay guys, actually we already have constant placed in our notepad, so I am going to copy this constant and insert constraint by head source, header create source. I'm going to create a file constraint. I'm going to paste that constraint at here. Actually, we are going to test this design in ZedBoard, so this constant is taken from ZedBoard master sheet. So you can see you can see ZedBoard master XDC. You can download it from Xilinx.com or Digitronix or Abinet. So we are just take it from that, and we have customized according to our leads output. So we have just edited this section, so you can do it yourself. I think T22, T21, and you can also see the location. This location at your ZedBoard also. You can see T22, which is actually I think left one lead, and another is right one lead, U14. So these are the leads. So let's close this constant. Now we are going to implement it. We haven't implemented, so we have also collecting the process we are going to follow in ahead. So we are going to implement it, generate, and we are going to export it with BT-stream. Then we will launch SDK, then we will create a new project, empty application, then we will insert some C program for processing system, then we will run it and program it on FPGA. So let's click on generate BT-stream. It will do previous process also. So let it did. So okay, it again synthesize the design. Actually we must have inserted our constant previously, then after we should follow synthesis. We have did oppositely, so here is some time taking symptoms. So let's wait, and let's wait for BT-stream generation. So guys, here is a process what we need to do ahead. So we have almost generated our BT-stream. We are going to export it. We are going to launch SDK. So we are going to create a new application, employee application project. Then we will add drivers. Actually drivers you can get it. These are the drivers. You can go to IP repo. Which IP we have just created. Go to lead controller. You can go to drivers, lead controllers, source. Here are drivers of lead controller C and S file, header file, and C file, and you can also include this self test also. These are the drivers, and we have another source also, lead control source, which actually gives instruction to the Zynq PS, which calls lead controller.s, which driver we already have seen it. This is the default header file, so it has set lead value to 255 actually 2 to the power 8. So we have also set some delay of 1000, so it will create a like a 1000 time revolution of 100 megahertz clock. So it will create a 1 second of delay. Actually this is kilo, this is mega, so actually it creates 10 second of delay, I think. So then we have initialized this register value, base address register, and we have one loop instruction which will print the value of late number which we are going to blink, so it will also increase the value. So after one late blinks, then other will be blink also, so we have also a delay. So this is the program for processor which instruct the late control, and ultimately it gives the instruction to our late control IP which will perform the late blinking procedure. So this is the source for late controller. You need to edit. Then after we are going to program FPGA, and we will open terminal. Actually terminal can be created I think window, there is some navigator, then you can get terminals. So you should set up terminal with this power grid, and you should connect another USB cable with USB UART to your PC. You have just connected a programmable cable with your PC, so you need another cables too. Then you can run your project as launch on hardware GDB. Then you will get status of layer and terminal in your ZedBoard and terminal 2. So let's have a fun. So we will going to show you a demo in next tutorial. So this will be much for this session, so keep streaming in our channel. So thanks for watching. Thank you guys.